Hey there, Calc kids. We're looking at 3.3b, more calc rules, more derivative rules, okay? Remember, don't drink and drive. That's a joke. So, your product rule, okay? That's the first rule we're going to talk about today. It's pretty important. And here is the rule. What it says is if you have a function times a function, you can break that up and take one function times the derivative of the other plus the other function times the derivative of the first, and that will give you the derivative of that function times a function. Another way to write it is if you have function u times v, well, your derivative of that is equal to u times v prime plus u prime times v. Okay? So pretty much you have to take the derivative of both functions, times it by the opposite original, and add them together. Well, let's just see what happens. Let's just take a look at an example and see if it clicks. Okay? Let's use the product rule. Now, you might tell me, Mr. Williger, can't I just FOIL this out and then take the derivative of it the good old-fashioned way? And my answer to you is yes, you can, but I just want to make sure you know the product rule because you can't always do that. Okay? So, here we go. This is going to be my u. This is going to be my v. A function times a function. So I need to have four things. I need my u, which is x to the third minus 4. I need my derivative of u, which my derivative of x to the third is you bring the 3 out in front, you subtract 1 from your exponent. Derivative of negative 4 is 0. Constants, remember, go away. Okay. Now I have to take a look at my v, which I made in red. My v is x squared plus 3, right? So my v prime, the derivative of my v, bring the 2 out in front. Bring my 2 out in front. 2 minus 1 is 1, so I get 2x. My derivative of the 3 goes to 0, so it's just 2x. Now I have to use my formula, and my formula is u times the derivative of v plus u prime times the normal v function. So I just plug it in. Okay, that's safe, it's getting in the way. So my u is x to the third minus 4. V prime is 2x, right? Plus my u prime, that's my derivative of my u, is 3x squared times my original v, which is x squared plus 3. Okay? And then all you do is have to distribute, add like terms, and you're done. So let's take a look at this. That 2x has to hit both those, so you get 2x to the fourth minus 8x, right? Plus 2 has to hit both of them. 3x squared times x squared is 3x to the fourth plus 9x squared. So we combine our like terms and we end up with 5x to the fourth plus 9x squared minus 8x, and that is our derivative of our original function right here. Ta-da! Ta-da! Okay, that's one of our two rules. Quick time. Okay, I'm back. Next is the quotient rule. Similar to the product rule, but not at all. The quotient rule is if you have a function on top of another function, and you need to find the derivative of that. This comes up a lot more, and sadly, it's a lot tougher. But it's not too bad. You still have to do the same things. You have to find your u prime, your v, and your v prime, and then plug them into a formula. Now, I know your question is going to be, Mr. Williger, are you going to give us this formula? And the answer is no. Okay, let's get to it. Another way to write it, the way I would write it, would be if you're trying to find your derivative of this beast, it's v times u prime minus u times v prime. So it's your bottom times the derivative of your top minus your top times the derivative of the bottom all over the bottom squared. Okay? This is the way I'm always going to write it. This is the book way your book says it. They both say the exact same thing. Okay. Order matters on this one. It didn't matter before. That subtraction really throws a monkey wrench into things. Okay. So let's use the quotient rule. So I have my u over v, right? So my u is x to the third minus 4. My v is x squared plus a 3, which means my u prime is 3x squared. Because you bring the 3 out in front, subtract 1 from 3 for your top, and then that gives you your derivative, and then your v prime, bring the 2 out in front, 2x, 3 goes away, you get 2x, right? Okay, now use my formula, which is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so I need my v, x squared plus 3. I'll even, that's my v, that's my v, that's my v, right? Almost knocked everything off my desk. That would have been this. You know what? I'm not even gonna pop. I'm just gonna take care of this right now so you guys can digest what's going on. There we go. There we go. Nice and tidy workspace. Okay, times my u prime, which is 3x squared, derivative of my top. So again, I'm getting that from. Can you tell that's a different color? Not really. Okay, so that's my u prime minus the top, which is my v. I'm sorry, my u. Times, why am I using the British accents? I don't know. The derivative of your bottom, which is 2x. Okay. All over the bottom squared, or your v. And that is actually the same thing as that. So I had to use that color, right? Just to kind of show you where I got everything from. Okay? So that's all there is to it, right? But wait, you gotta make it look like something good. It looks like Easter up here. Okay, I'm gonna take this piece, distribute it through to both those, so I get 3x to the fourth plus 9x squared, right? I'm going to take this 2x and distribute it to each of these. So you get your 2x to the fourth minus 8x. Take this negative sign, and that has to hit both those two, right? So it's minus becomes a plus. All over x squared plus 3 squared. Combine your like terms and simplify. Get out of here, you save button. So you get x to the fourth plus 9x squared plus 8x all over x squared plus 3 squared. Phew! I'll let you guys digest it. I gotta do another quick. I looked at our last example and I realized I already taught you how to deal with negative power, so I'm gonna let you guys kind of try that probably yesterday. So here's the plan. I showed you one example of product and one example of quotient. Tomorrow your warm-up will probably be a product and a quotient, and then I'm going to do a quick remind me to show you. I'm going to give you a problem that you have to do both in one problem. I'll do that in class so that way if there's any questions I can answer right there. But this will kind of give you a head start on all. Keep it short and sweet. Have a lovely day.